So in this chapter, you read about fixed and variable expenses and CVP analysis, or cost volume profit analysis. And what that does is it breaks costs out to fixed and variable. And that way we can use those costs to look at a lot of different situations and how they might affect our business. So we have our fictional company here, Digital Phone, and they distribute specialized phones, and they pay sales commission on each sale. So we have a breakdown of the fixed and variable costs. We can see that they sell the phones for $75 each. They have variable expenses of production and commission. So their total variable expenses are $45. So we can easily calculate their contribution margin. Remember, we can take sales minus variable costs or expenses. We use the terms interchangeably here. That equals contribution margin. So we need to know that in order to calculate break-even point and a lot of other types of data. We can see here we have their fixed expenses, and those total $260,000. Okay, so we're asked to calculate the break-even point in dollars in sales for Digital Phone. And what I mean by that is units. So how many units do we have to sell? And what are the actual sales dollars that they're going to have to earn in order to break even? So remember, to calculate break-even point in units, we have to take fixed expenses over our unit contribution margin. Okay, and we already calculated that up here, or we should calculate it up here. So it's going to be the 75 minus the 45, right? Our sales minus our variable costs. So our contribution margin is going to be $30 per unit. So we know our fixed expenses are $260,000. We divide that by the contribution margin of 30. We're going to get 8,000. Should be 8,000. We got an extra zero here. Okay, so we probably want to round this off because it's not likely that we're going to have fractional units. So I'm just going to take the zeros out of there, the decimal points, and we're going to say it's 8,667 units. Now, in order to get break-even point in sales in actual dollars, we could do fixed expenses over contribution margin ratio. But that requires another calculation. An easier way to do it might be to just take the sales price and multiply it by the number of units we need to break even. So if we were to take the units and multiply it by the $75 sales price per unit, we should come up with $650,000. So in order to differentiate this, we should make this currency style. These are units, these are dollars. So we would need to sell $650,000 in sales, or in sales, to break even. Okay, so in other words, we need to sell 8,667 units at $75 per unit in order to break even, or have a net income of zero. Okay. Now, when we look at B and it says, if 20,000 phones are sold this year, what will the net operating income be for Digital Phone Company? So now that we know what our fixed and variable costs are, we can calculate this. And so we can do our sales. And we're going to do this just as kind of a partial income statement because we have all the data up here. We don't need to repeat it all down here. And then we're going to have our contribution margin. And then we will do our fixed expenses. And we will have our net operating income. So 20,000 units, okay, or 20,000 phones at $75 per phone is $1,500,000. Our variable expenses, $45 per unit total, including production and commission, times the 20,000 phones. That gives us 900,000. So our contribution margin is going to be the sales minus variable expenses, just like we did up here. Okay. All right. Our fixed expenses are 260. So we can calculate our net operating income by taking our 600,000 in contribution margin minus the fixed expenses. So that will give us a net income or net operating income of 340,000. So when we do a contribution margin income statement, in order to get our net operating income, we're going to take our contribution margin minus fixed expenses. Okay, so in this case, net income would be 340 if this situation were correct. Now, when we use sensitivity analysis, we can change things and see how that would change our net income. And that's why it's called sensitivity analysis, because the costs are sensitive to these changes. So it says to us here, if commission is increased by $1.50 per unit sold, and the result is a 12% increase in unit sales, what will the new net operating income be? Well, we have commission at $5 per unit, so we're suggesting it goes up to $6.50 per unit, which would bring our total variable expenses to $46.50 per unit. We are expecting a 12% increase in unit sales. So let's do it out. So we could just copy this. And we can take the 20,000 units, okay? So we're saying if we had 20,000 units and now we're expecting a 12% increase in unit sales, not in dollars, but in unit sales, we can multiply that times 112%, or 1.12, times the $75. That's our sale price. That gives us $1,680,000. So as expected, our sales are higher. How will this affect our variable expenses? Well, let's take the 20,000 units times 1.12, or 112% again. But now we got to remember that our variable expenses are now $46.50 per unit, not $45. So that gives us variable expenses now of $1,041,600. Okay? So it's higher than we had in scenario B. However, the key here, we know the fixed expenses are the same. So the key here is the contribution margin higher. So let's find out. We'll take our sales minus our variable expenses, and we have $638,400. So it is higher. So if we expected this scenario to work out the way that it's showing, it would definitely be the way to go, because we would have a higher contribution margin, and as a result, with the same fixed expenses, have a higher net income. Okay, so in this case, our scenario C is better than scenario B. In the next video, we'll see how scenario D and E work out compared to this. So thank you for your attention.